Tonight's lesson is lesson 81, and this is the first time that we are reducing fractions. So this is the first part, but we will do it again later on. In lesson 79, we practice making equivalent fractions by multiplying by a fraction named for 1. We change the fraction 1/2 to the equivalent fraction 3/6 by multiplying by a fraction that's equal to 1. So we know that 3 over 3 is going to be equal to 1 because if we have 3 pieces and we have all 3 of them, we have 1 whole. So I multiply across. 1 times 3 is 3, 2 times 3 is 6. So this is an equivalent fraction. Multiplying by 3/3 made the terms of the fraction greater. The terms of a fraction are the numerator and the denominator. The terms of 1/2 are going to be 1 and 2. The terms of 3/6 are going to be 3 and 6. Sometimes we can make the terms of a fraction smaller. So when we were finding an equivalent fraction, we were making them larger. But when we are reducing fractions, we're going to make them smaller by dividing the fraction for a name for 1. So in 79, we multiplied by a fraction that was equal to 1. When we reduce fractions here, we're going to reduce by a fraction that's also equal to 1. So the same thing, we're dividing by a fraction equal to 1, just like we multiplied by a fraction equal to 1. So here, we are changing our 3/6 into an answer by dividing by 1. So if you see, this is 3/3, we're dividing by technically 1. So 3 divided by 3, whatever I do the top, I do the bottom. 3 divided by 3 is 1. 6 divided by 3 is 2. So an equivalent fraction of 3/6 is 1/2. And this is reducing. And I wrote, changing a fraction to an equivalent fraction with smaller terms. So 3/6 and 1/2 are equivalent. We know that. But it's in smaller terms. We're reducing. The word reducing means to make smaller. Alright, so we're going to try the first example. And we can do this one together. Reduce the fraction 6/8 by dividing both the numerator and the denominator by 2. Alright, so this one I'm going to write my fraction 6/8. I need to divide, my directions say, the numerator and the denominator by 2. 2 and 2. Alright, and if we notice, 2 over 2, or 2/2, is also equal to 1. So, like we did before, when we multiplied by 1, we're now dividing by 1. We can go across. You take the top and go across, and the bottom and go across. So, 6 divided by 2 is 3, and 8 divided by 2 is 4. So you can reduce 6/8 to 3/4 by dividing by 2 over 2. Now, one way that you can figure this out is if you look at your 6/8, if you were to look at that first, I have two terms here. I have a 6 and an 8. So I kind of just write that down. And I look at my two numbers and I say, okay, what number can go into both of them that I can divide them by? Well, they're both even, so 2 fits in. So I could divide them by 2. I couldn't divide them by 3 because 3 only fits into 6. And I couldn't divide them by 4 because 4 only fits into 8. So the number that we divide by has to equal, or has to fit into both of them. And then since 2 fits, we divide it by 2 over 2. We have to turn it into our fraction that's equal to 1. Not all fractions can be reduced though. Only fractions whose terms can be divided by the same number can be reduced. So like I told you, 2 fit into both 6 and 8. So we were able to reduce them. Sometimes when we have a fraction, not 6/8, but another fraction, which we will see later, there won't be a number that will fit into them. Kind of like how we talked about prime numbers. A number like only 1 in itself will only fit in. So that's a fraction that cannot be reduced or is already in its simplest form. Okay, we're going to try the next example, and it says, which of these fractions cannot be reduced? So I need to look at my terms and decide, do I have a number that fits into both of them that I can divide by? Alright, so I'm going to start with 2/6. And if I look, my two terms, I have a 2 and a 6. Well, first of all, I noticed that both of these numbers are even, right? So they can both be divided by 2. So if I were to take 2/6 and divide by 2, 2 over 2, I would get 1 over 3. So that can be reduced. All right, let's go to the next one. My terms are 3 and 6. What number can fit into both 3 and 6? 3. So I'm going to divide my top and my bottom by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Oops, I wrote 3. 2. So, 1/2. 6/3, or 3/6 reduced is 1/2. 2/6 reduced is 1/3. Alright, now my terms are 4 and 6. Again, I look and I can tell, okay, they're both even numbers, so I know for sure 2 can fit into both of them. So I'm going to go ahead. 3 doesn't fit, and then we're back at 4. So I'm going to divide by 2. 2 over 2. Remember, we're dividing by 1. So if 2 fits in, I'm going to divide by 2 over 2, because that's equal to 1. And I just go across. 4 divided by 2 is 2. 6 divided by 2 is 3. Alright, so 4/6 reduced down is 2/3. And my last one, 5/6. So my terms are 5 and 6. Well, is there a number that can fit both into 5 and 6? Besides 1. 2, they're not both even. 3 doesn't fit. 4 doesn't fit. 5 doesn't fit into both of them. And 6 doesn't fit into both of them. So when something like this happens, I know that this is already reduced into the smallest terms, and I cannot reduce it. So which of these fractions cannot be reduced? 5/6 cannot be reduced. We cannot make it any smaller. It's already as small as I can get. Alright, try number 3. See if you can do it by yourself. It says add 1/8 plus 5/8, then reduce your answer. Alright, so I'm adding, and this is something that we are very used to, 1/8 plus 5/8, and I add straight across. 1 plus 5 is 6. When I'm adding, I don't change my bottom because I'm just adding pieces onto it. My denominator, so my answer is 6/8. And I need to reduce this answer. I need to put it into its smallest terms. So I need to I have a 6 as my term, and an 8 is my term. I'm trying to find a number that could go into both of them. Well, they're both even, so 2 would work. Okay, so I take 6/8 now. I'm just going to kind of draw a line here. 6/8. We chose 2, so I'm going to divide by 2 over 2. Top number, your numerator. 6 divided by 2 is equal to 3. 8 divided by 2 is equal to 4. So 6/8 reduced is equal to 3/4. Alright, and the next example says subtract 5 and 5/6 minus 2 and 1/6. Then we have to reduce our answer. Alright, so go ahead and subtract your fractions. Again, this is something that we've done before, so it should come naturally to you. Alright. Now there's a couple ways that you can subtract. I'm just going to write my problem out again. 5 and 5/6 minus 2 and 1/6. I'm going to go ahead and subtract my whole numbers first. Remember, you can do your fractions first if you like to do that, but I'm going to subtract my whole numbers. 5 minus 2 is 3. 5 minus 1/6 equals 4/6. Okay, and now I want to reduce my answer. When I'm reducing here, I'm not going to touch my whole number because that's already, it's separate. It's just a whole number. What I need to reduce is my fraction. So I have 4/6, which means my terms are 4 and 6, and I need a number that can go into both of those numbers. They're both even, so we know 2 will work. So 4 over 6 divided by 2 over 2. 4 divided by 2 is 2. 6 divided by 2 is 3. But that's not my answer. Remember, I got to go back and put my whole number. So my answer would be 3 2/3 would be my reduced answer. 3 is my whole number, and 2/3. All right, and here's your lesson practice. You have some subtraction of fractions, some adding of fractions, some multiplying, and then you need to reduce these 3 fractions.